Okay, so in this video, we're quickly going to just introduce sequences. Probably won't get a chance to look at series, but I want you to get a feeling and a start of this. So right now we have a definition of sequence in front of us. A sequence is a function whose domain is a set of positive integers. Okay, so positive integers 1, 2, 3, 4, 5, etc., whose range is a subset of real numbers. Okay, so what I just said with my integers, that's an example of a sequence. 1, 2, 3, 4, 5, 6, etc. Sequences are just like functions, except that when we plug in our value for a variable, it is a positive integer. Instead of writing it in function notation like f of x or g of x, we're going to write our sequence notation as following. So let's say a sub n. So in this case, n is going to be my positive integer that I plug in. And a sub n, let's say, is the set such that n divided by 2. We say that numbers that are a part of our sequence are elements of the sequence. Or terms of the sequence. So if I wanted to find the first term, of the sequence, I would just let my n be 1. So looking at this, a sub 1, all I'm doing is I'm going into the formula that it gave me to find my terms of my sequence and plugging in 1 for n. So in this case, I would have 1 divided by 2, which is 1/2. So to find the second term of the sequence, I would look at a sub 2. So I'd go in wherever I saw an n in the formula of a sub n, I'd plug in 2, and I'd get 2 divided by 2, which is 1. So continue on. So a sub 3, plugging in 3 wherever I saw an n, I would get this is equal to 3 divided by 2, or 3/2. And so my sequence, a sub n, is going to be the set of numbers 1/2, 1, 3/2. It's going to go on forever, so I can put these 3 dots. That means that it's continuing on forever like that. We can plot these if we want. Think of these like points. When x is 1 or n is 1, I have 1/2. When n is 2, I have 1. When n is 3, I have 3/2. So I'm just going to have these points when I'm plotting a sequence. I'm not going to join the points with a line because the numbers between our integers are not going to be part of our domain. So let me pull up another example. So looking at our next example, we're given that c sub n is equal to -1. That -1 is raised to the nth power, and then that's all divided by the quantity n plus 1 times that quantity n plus 2. The directions asked for us to find the first 5 terms of this sequence. So all we're going to do is we're going to look at what is c sub 1. So we're going to go in here, and wherever we see an n in our formula, we're going to plug in 1. And so c sub 1 is going to equal -1 raised to the first power, all divided by 1 plus 1, and 1 plus 2. So simplifying, -1 raised to the first power is -1 all over 1 plus 1 is 2, and 1 plus 2 is 3. So 2 times 3 in our denominator gives us 6. So our first term on that sequence, c sub n, is -1/6. So now do the same thing, but now going in and plugging in 2 wherever you see an n in that formula. So we have -1 squared all over -1 plus, 2 plus 1, and 2 plus 2. Well, if I square -1, that's positive 1. All over 2 plus 1, which is 3. 2 plus 2 is 4. 3 times 4 gives us 12. So C sub 3, we have -1 cubed all over 3 plus 1 and 3 plus 2. Well, if I cube a negative, I get a negative. So this is equal to -1 in my numerator, 3 plus 1 in my denominator, that's 4 times this 3 plus 2, which is 5. 4 times 5 gives me 20. 2 more. So now go in and plug in 4. -1 raised to the 4th power is positive 1. I'm going to have 4 plus 1 in the denominator, which is 5. And then I'm going to have 4 plus 2, which is 6. So I have 5 times 6 in my denominator, which gives me back 30. One more, so C sub 5, -1 raised to the 5th power, that gives me back -1. 5 plus 1 in the denominator is 6, and 5 plus 2 is 7. So 6 times 7 gives me 42. So C sub 5 is -1 over 42. So C sub n, the first 5 terms, I have -1/6, 1/12, -1/20, 1/30, and -1 over 42. It's carrying on, so I'm going to put dot, 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 and then close my set, these curly brackets. So you'll see that when we are given the terms of a sequence and we want to work backwards, certain things are going to be helpful to see. Notice that we have our signs changing from negative to positive, negative to positive. So a way to do that is raising -1 to that nth power. If we want to start it with a negative number, if we want to start with a positive number, we could raise that exponent to n plus 1. And we would start with a positive, then negative, etc. And that's just an introduction to sequences. You could probably start a little bit on the homework, but I will finish this section up next week.